Thank you very much. My name is Andreas Møller, and I've got my Twitter handle as well, if you want to shout out a question online. I currently work for a company called Celindo, and we do 3D visualization of online products. So we do furniture visualization is our main focus right now, and we also just started doing these style shots as well. So basically, every image you're going to see in this presentation is first of all going to be 4K. It's going to work really well on the screen, and also it's going to be entirely computer generated by our render artists. So I just wanted to plug that in. This is sort of the core of our product. We create these 3D models and we render them in really high quality, so you basically get to see online what is it actually you're purchasing. I'm here today to talk about something called type-driven development, and that's because everything that's cool has to have a driven development attached to it. That is the rule. And type-driven development is really about data modeling. It's about going back to a concept of saying, if I want to build a large application, a large software system, I want to start by considering how do I actually model that real world thing in my program or in my distributed system. And it's a practice that used to be incredibly common back when I went to university. We were drawing UML diagrams and we do courses in software engineering, and we all talked a lot about the software design, and the second we hit the job market, we go, never again! Never anymore do I want to do that. And there is a reason for that, because it was really boring. But at the same time, it turns out if you spend a little bit of time considering how you're actually going to model your problem, or your business domain is often called, you can end up saving quite a lot of effort down the road. Now, one of the big sort of things inside, that works out well. One of the big Bibles in this domain is a book called Domain-Driven Design. And it's a very nice book. I would definitely recommend reading it. If I had to sum it up in a sentence, it basically comes down to saying, you shouldn't just go out and try to model it as a software developer. You need to understand the business you're trying to implement. So the process of modeling a software system or building a software system has to start with communicating with the people that actually come from the world you're building for. I'm currently working on a small side project where I'm doing a report generation app. So I'm going to use that as an example going forward. But the focus when modeling has to be, first of all, understanding what kind of problems do people have. What kind of entities exist in that world? What kind of things has to exist in our system? How do people talk about it? And as you do this and you build up this model, you create a shared language, generally between both you as engineers, but also as the business, any part of the organization that interacts with that. So you have a shared understanding of what does these terms actually mean. Now, once you've done that, at least in your brain, the next thing is you need to formalize it, because maybe not everyone was at that meeting, and also people come by later. And of course, you tend to forget if you don't write it down. So we need a way to express how our system looks. And you can read the MySQL tables if you run that in the background, but it might not be the best representation of how your system actually works. This is why UML became very popular, is because it's a formal language for describing information systems. UML is not very fashionable anymore. And one of the things I want to talk about here is that there's new tools coming out that actually can be really powerful for helping explain this, for helping us express this problem. Yes, so that's why I want to talk a bit about type systems. And JavaScript famously doesn't have one, or at least not one that you ever talk about, until recently, when now I believe it has at least 4. It started out with prop types, came very early. Facebook made Flow, which is really popular. Microsoft made something that we're not going to talk about. And we also have GraphQL, which is actually a library for building web servers, but also comes with a very powerful type system. And I've chosen to use GraphQL as the example we're going to use here, but pretty much everything we're talking about can be easily translated to any other type system, at least any other of the ones available for JavaScript today. And fundamentally, a type system or a type is a way of talking about our data or information and adds some restraints to what they can be. So it's kind of a meta language to talk about data structures or data in our programming. So in my case, which is going to be very hard to read, I'll try. We have something called a report. A report has a title, which is a string. We have an author, which is of type user, which we have later on, and we have a bunch of pages. It's a very dumbed down definition. And we can always say, if we were just talking about this, we would still say it has title, author, and pages. But the benefit of the type system is that we are giving a lot more information here. So we're, for example, saying that title has to be a string. That was probably obvious. In this case, we're also given the exclamation point, which in GraphQL means it can't be null. Has to be there, has to be a string. Author is the type user. In this case, we haven't quite defined that yet, but we know it has to be there and can't be null. And we know we have to have a list of pages. Our user, we give it a name, we give it an email, and a user can also have a list of reports that they're the author of. And finally, we have a page, which is really hard to read, but it basically says it has title, text, and it refers back to the report it actually does. So when we say GraphQL, the graph part is essentially because our GraphQL data structure is a graph. It can be circular, it can link back. And the way you use GraphQL, if people are not familiar with it, I'm going to do like a very short 2-slide introduction to GraphQL, so we're not going to go into detail with that. But you send it a query saying something like, I would like some reports, and for the reports I'd like the title. I also want the author, and when you send me the author, give me his name and email. I also want the pages in that report, but I only care about the title and text. So if there's anything else, just ignore that. I'm describing exactly what I want here. And it'll then send a bunch of data back that is excellently formatted, that basically represent that exact structure we get. So the very idea is saying, rather than doing a REST endpoint, where the programmer defined exactly what you have to ask for and what comes back, here the person making the request says, I want this and this and this and this thing. And these queries can become more and more complicated. You can, as long as you say a page refers back to a report, you could keep going down that saying, get me the report for the page and then the page for the report. Don't think you should do that, but it's possible because we're querying a graph. I'm not going to go into more details about how that works now. If you're not familiar with GraphQL, I really recommend looking into it. It's an amazing technology. But the point here that I care about is the type system, because it comes with a beautiful type system. And especially the type system's ability to express how our application works and how our data works, how our data is modeled. So other than, of course, being a way of formalizing it, or saying, a report has a title, author, and pages, it also allows us to create some restrictions that weren't necessarily obvious in normal conversation. So I might have a situation where a report has to have at least one page, because it's really weird to render them in a list if I can't show the front page. So I might go and say, that's a restriction on my data model, that it has to have a page. There has to be a front page. And if there's not a front page, that's a problem. So in this case, we can see we have a list, but we know list can be empty. So currently our definition of report doesn't actually satisfy this property that our business has. So I have to implement that in business logic on the server, right? If you try to delete the last page, it goes, no, you can't do that. Another way of approaching is saying, what if I can change my model to actually solve this problem for me? What if I can make my type system, in this case, express that this is a condition that can't happen? So I could do something like this, where I'm saying, actually the front page lives on its own, and I say, we give an exclamation point, it can't be null. So it's not possible to create something of type report without it having a front page. And then every remaining page we put into the list of pages. So without implementing any business logic in the server, just by making this change, we've now actually gone and put in a guarantee that we know that reports are going to have a front page. This is very useful for us to prevent errors, but it's also incredibly useful for communicating this data model, because when I read this, I also know immediately that it has to have a front page. So I know this is a restraint in our system. I know this has to exist everywhere. So as a tool for communication, that kind of thing is incredibly useful. Another thing we can do is, in this case, we have our little user type. Again, these are somewhat simplified. Doesn't really get that simple in real life, but so we have a user. He has a name that's a string. That makes sense. Names generally are. Email is a string, which we like to think they are, but if we really are honest, they're kind of a select subset of strings. Like there's a lot of strings that aren't really usernames. In terms of names, you could argue that, but I don't want to be the person that go around telling people that they don't have real names. So we'll leave that to be whatever people want it to be, right? But for email, actually not all strings are valid emails. This is again something we have to go and implement in our server-side logic, because that's not part of our, we have to go and say, actually we need to validate this and make sure that that's true. But then as long as it's a string, we don't communicate that. When people read our model, read the information about our model, they can't actually tell that, other than if they happen to know what an email was, right? So one thing we can do is what's called in GraphQL a scalar. Different type systems have different names for this, but we're going to stick with scalar for now. And what it basically says, I'm going to create a basic type. That's an email. And I'm not going to tell anyone what it is, other than we all know it's an email. And GraphQL then goes, if you use this type in GraphQL, it goes and says, you need to define how do I pass an email? Like if I get something that's an email in, how do I read that value? And also how do I serialize it? In this case, reading the value probably means reading in the string, running it through email validation, and then thereby returning the string as is, as type email if it's valid, or throwing an error if it's not. So our type system now guarantees that emails are valid emails simply by having this model. I know that I'm not going to try send an email to something that's not an email. And again, the more important bit is that I communicate that. So when I talk about how my system works, when I talk about the string, when I tell my front-end developer or back-end developer, depending on where I'm working, that this is what I'm sending him, he has all that information. I don't have to explicitly tell him, has it been validated, has not been validated? Information is right there. So we communicate in a language that's very, very expressive, simply by telling him telling people what types it is. We also have enums. If you're a JavaScript developer, this is madness. Nobody understands this. If you've worked in pretty much any other programming language, you know what it is. It's basically a way of saying, this is something that could be one of these values, but only one of these values, right? So in this case, maybe I have a report state. It could be inactive before I've made it public. It could be active, or maybe it needs a review from someone. It kind of depends on the business. This is a very thought out example. Enums, again, super useful because in JavaScript, we would absolutely use the string normally here. It's just a string, but it can only be one. But we're not going to say that. We just all know. And the problem is that eventually someone doesn't know. Eventually, the fact that we didn't express this part of our model correctly and clearly enough ends up hurting us in the long run. So the ability to be incredibly expressive with our data modeling and with our types really helps us communicate to the rest of the organization and to our future selves, often quite important, what actually goes on here. And there's a lot of things here where we don't need to go and write a validator that checks that if I get some string that's one of those, I have to throw an exception. We don't need to do that. It's all handled. The type system did that for us. It's explicitly built in to our types that cannot happen. Well, that's one's good, isn't it? Right. Yes, formatting works really well here. So I have one more thing I want to add about types in this case, which is, let's say we want this report to be sent out to a bunch of people at any sort of recurring interval. Basically the same as all your recurring events in Gmail or Google Calendar, whatever you use, but for our reports. We need to be sent out at a regular interval. We generate a new report and we send it out, right? So there's a lot of way where we could model this notion that something has a schedule. But a schedule can either be weekly, it can be monthly, it can also be every 30 days, which is fun for all programmers, not the same as monthly. Would be really lovely if it was though. Or any other sort of definition of what a schedule means. But it can only be one of them. So we can't go and say, oh, this has to be done weekly on the 1st of the month. That doesn't make any sense. So when trying to model this notion, we need to represent the notion that something can be one of multiple states, kind of like an enum, but we need a bit more information, like, for example, with the weekly, what day of the week do we actually send it out on? So we could model it like this, where we say we can create a type called weekly, and we'll tell it what day of the week is. In this case, weekday is an enum of Monday to Sunday that I didn't have room for. And we can say things like what day does this thing start on? When does it have an end date? End date is now actually, should probably not have an exclamation point because maybe it doesn't have an end date. Again, had I been a little bit better at that, I would model that a little bit better and say, okay, we can now explicitly say end date can be null. It might not exist. And we can be explicit about that, even though I technically wasn't. And then we can define our schedule as something that's either a weekly or monthly for this case. And the benefit here is saying, if I had to model this in JavaScript, I might go and say something like, okay, so what's our schedule recurrence? And then I'd give that a string weekly. And then I'll go, so like, okay, but I might add a day of week if it's weekly, and I might add a day of month if it's monthly. But my problem here is that it's not actually explicit in the language here I'm talking in. Because I could potentially have a monthly recurrence and a day of week added to that model. There's nothing preventing me from doing that, other than it probably causing a lot of problem down the line. So by doing this, we're allowed to be incredibly specific about what is actually valid, what can actually happen, and what can't. And that helps us when we run the program, because we can now have our compiler or preprocessor in JavaScript world do a lot of the work for us that we normally have to do at runtime. But it also helps us when we talk to our teammates, because we can be very explicit about how does the data in our system actually work. GraphQL, as I mentioned, is quite a wonderful tool. And if you haven't looked at it yet, I definitely recommend you giving a look at it. I don't want to do a deep dive into GraphQL, because it actually takes a little while to quite understand how it works, and it's honestly better done going through this documentation page. I think there's probably been GraphQL talks as well. Have there? No, we don't know. Okay, someone should do a GraphQL talk. That would be a great idea. After they wrote their blog, they should do a GraphQL talk. That would also give you a good choice. But one of the things that is really amazing about GraphQL, as I said, the type system, is that it actually allows us to build really amazing tooling on top of it. If you know GraphQL, you're probably familiar with, I'm going to sneak in and do this one. That didn't work. Localhost. Was I close? 4,000? So we have, that barely shows. Okay, so it comes with a query engine that allows you to run queries against your data, where you can go and say, I want reports and I want like title, which won't work because I was too lazy to actually implement the server, but it just have the type system. But it comes with a query engine where you can go, just like if you use Postman instead of REST, you can go and query your data. You can go and make live queries as you develop, try to figure out how these things work. And more importantly, oh wow, that worked out great, didn't it? You can zoom out. Well, I can't because it's outside the window. Yeah, maybe. Yes, a bit. Right, this is going to be the least climactic part of the talk. Essentially, because we have a type system, because we have very strictly defined what the data looks like in GraphQL, we can build tools like someone built this tool called Voyager that actually generates a graph, a UML-like diagram of what all our data in our system looks like. And then we can use this and say maybe we have business people who don't quite want to read our type definitions. Maybe they're a bit weird like that. But we can use this as a way of communicating between different parts of the business as a way more graphical and easier adoptable way of saying, this is how the data in the system looks now. Both to actually help them understand it, but also to help us find problems with it. To help them saying, well, we don't actually, in our world, we don't call that a report, we call it a monthly reminder, or whatever they call it. And we can use this as tools to collaborate and build better models together. So, back to... Aha. Yes. Yeah, we also had one. Thank you very much for your time. I think it was a bit short. Is there any questions to this? I know I covered a few topics very shallowly, so.
Okay, but first give it a hand. Does somebody have a question? I have 1,000. Yeah.
Does the enum means actually a number in database, or does it mean the string, the enum?
In especially in GraphQL, it actually becomes a string.
The string. So
Yes. Yes.
Yeah. So how you are actually handling like the definition of the schema between the backend and the frontend? You know, there is some fight.
So what actually happens there is that the same way that Voyager, the tool that visualizes does, it can go and ask GraphQL server, any GraphQL server set up, you can go and ask it for its schema, which is like a JSON representation of the type system. And it'll send that back, and from that you can then, the front end will know what is actually valid to do, what's not valid.
No, sorry.
Yeah.
I didn't clarify that one. But for example, when you are in the process of defining the schema,
Yeah.
like you have a user, you should name a title or name or first name, you know what I mean?
Yeah.
Like when the front end and the backend, they both involved in designing the schema. Like how do you get to agree? Is it like the schema defined by the front end or the backend, or there is like in between process, the product team?
Well, generally neither. You want to go and figure out what these things are called in your organization. One of the beautiful things about GraphQL especially is that you don't have to build your API for the front end. The front end can just query the data it needs. So if you want, in my case, I just had a name, and normally I would put first name, surname, but it was already a small screen, and I didn't have a lot of space, I just got a name. But what the definition of depends on the conversation you have in organization. Do you need to ever just show the first name or surname? If you only ever need to show the full name, I suppose it's fine. And you have similar concerns with like, maybe I don't even need an email. Is email optional? Do I need one for this to work? Or do they not need to provide it? That depends on what your business does and what you need. And this is merely that once you've had that conversation, this is how you write it down, or at least how you can write it down. So how you formalize it. Yeah.
I've had that a few times where a user had 3 different models, sometimes with an optional email, sometimes with a very strict validating syntax of that email. How do you namespace this in your organization?
So I felt that especially before working with any sort of type system, I would go as far as say almost every time you need a user in JavaScript, there's a new type for it. Like, oh, this one has an email, this one doesn't need it. This one has just the full name, this one has a surname. We could just create a new version, right? Generally, in try and figure out whether we're talking about the same thing. So the first part is actually don't create 3 namespaces if we're really talking about the same thing. User pretty much like within the same application, a user almost always means the same thing. Or at least you have a core that's the user, and you might have things that build upon that. You might have an admin that had some extra features. You might have a certain type of role that had some extra features, but a user generally means the same thing. So in this case, I would very much try within at least one API, try not to namespaces, because if you need 2 different things for the same, like if they don't have, let me put it another way, if they don't have a logical different name, they're probably the same thing. And if they do have a logical different name, so one is like a manager, one is a user, one is an admin, or then the names generally come. And as a developer, these might not at all be obvious. But what often happens is that when you step into your organization and talk to the different kind of people, you have your customer representatives, you have your business, your sales, it's marketing. Any part of the business that deals with customers, start asking them, what is this kind of thing called? And usually they have a terminology that's in play. And if that works, the best option is usually to use that.
Where do you create these schemas? On the front end or the back end?
On the back end.
On the back end.
Yes. The server defines the schema, the front end queries so the query I saw before I went on.
The first one where you
Yeah.
select what you want.
So we define our schema on the server. We send a query to it from the front end.
Okay. The first page is in the back end, the one is in the front end.
Yeah.
Okay.
Last question.
Is that a PowerPoint or an app you developed?
The Pacman is there. This is called Spectacle, and it's developed by Formidable Labs. It's a React library, because anything that can be written in JavaScript, Spectacle. Yeah, yeah, because anything that can be written in JavaScript must be written in JavaScript, right? Like that's the rule. And also, it's the only one I knew where I could put our JavaScript furniture slider in without it breaking everything.
Last
Okay, so what if your schema then changes over time? Are there tools to help you out in the front end and the back end? Like
There is. This may actually be my favorite part of a type system, because when your schema change, your application breaks, and it's wonderful. Because when it happens in JavaScript, it doesn't break yet. It will eventually, because eventually you're going to try to ask for that field that doesn't exist anymore. So obviously, a bit of planning helps always. Like, do the conversations first. Go talk to your organization. Try and understand the relationships between the things you're modeling, and generally you're going to need less change. Or put another way, you're going to need more additive change, which is free, and you're not going to need to actually change fields or remove it, which is what breaks things. But if you break things, that's okay. Like generally, if you're building a server, like make a new version if you're going to break it. But in your organization, everything breaks right away. Like you know right now that you've broken thing. So you don't even need to run tests against that. Like it tells you when you try to compile it, going, no, that doesn't work. That's not the thing it used to be. I'm trying to ask this thing what's here. That's not what I thought it was. So immediately you get that feedback and you can solve all your problems right away. And this is one thing I often find in a pre-type system world, that refactoring and model changes get a little bit scary, because it takes a lot of time to sort them out, and sometimes you miss something, and then 2 weeks later in production, there it was. And one of the benefits of doing this early at compile time is that you're allowed to break things. Like you can break really big things. You can change, like a user can now have a first name and last name instead of a name. That's like just the number of places that could break in a JavaScript app with no guarantees. Like that's everywhere we render a user, that's gonna. And do you remember everywhere you render a username? Because with the type system basically going that it's there. These are the places where I mark them in red for you. So obviously you still have the same problem. It's not like it goes away. It's not like we don't have to worry about it. But if we do have to break things, it's really nice to know right away everywhere where it breaks.